Okay, so we're going to start off the Unit 8 discussions with a little bit of review on areas of quadrilaterals and triangles. So please follow along, take notes as you see fit. We're going to see a whole bunch of formulas. Some of them are review, some of them might not be. Okay, I would advise you to, at the very least, write down definitions and formulas. Okay, so let's start off with the basic information here. We're going to be spending a lot of time this unit talking about area. So we'd probably better have a basic definition for area. Okay. Well, the highly technical definition that I use says area is the amount of stuff required to fill a two-dimensional object. Now, what is stuff as far as the amount of stuff required to fill a two-dimensional object? I don't know. That's usually provided for you by the problem. Okay, but it's in usually the form of some type of a measurement: inches, feet, miles, meters, centimeters, millimeters, yards. Okay, that is stuff, whatever it is, whatever the unit of measurement is. Okay, that it is required to fill a two-dimensional object. Okay, so let's start off. When we were talking about the different quadrilaterals, we spent a ton of time talking about the parallelogram. We're going to start again with the parallelogram, just kind of like we started back then with it. The area of a parallelogram is found by multiplying its base times its height. Now, if I had to pin one thing on, okay, here is what students tend to mess up the most when it comes down to doing area calculations. The one thing we tend to mess up is trying to figure out where base and height actually are in a figure. Okay, well, it's not really a great mystery. Okay, the one thing you've absolutely got to get past is people tend to think of the word base as meaning bottom. And then we think of the word height as meaning top to bottom. Okay. Unfortunately, I mean, you're right. In the English language, that's what these words mean. In the geometry language, and we've mentioned this earlier this year, base typically doesn't have anything to do with being on the bottom of a figure, and height doesn't have anything to do with how tall something measures. Okay. In the world of geometry, base and height are simply two measurements that are perpendicular to each other. Okay, so for example, if you look into this parallelogram, okay, why is this guy the base, or these two the bases? Why is this guy the height? Is B the base because it's on the bottom? Is H the height because it's sticking straight up? No, base and height are base and height because they are perpendicular to each other. We could take this parallelogram, we could turn it over on one of its points, we could flip it upside down, we could lay it over on one of its other sides. Would that change the base and the height? They would still be in exactly the same place that they are right now. Now on the parallelogram, I see I've got the top and the bottom, in this case marked as base. Why do you think that is? Yeah, they're parallel. Isn't that a property of a parallelogram, that the opposite sides are going to be congruent to each other? Yeah, so it doesn't really matter in this case which side we call the base. Okay, so we could use either one. And as I indicated on there, that these formulas are on your formula charts. You will not have to memorize the formula to find the area of a parallelogram. Not that it's a difficult formula, and you've certainly seen it before. I believe the first time you actually get to look at finding the area of a parallelogram, I believe is in somewhere around 5th grade. I cannot move this progress bar here. Okay, so here is a parallelogram. Now, calculations like this, like finding the area of a parallelogram, it's a very simple calculation. So you should probably expect that there's going to be distractors in the problem. They're going to provide you with some measurements that you will need and some measurements that you will not need. As we're going to look at tomorrow, it's possible that they may not give you measurements that you do need. We may have to solve for them. Okay. Let's see, an area of a parallelogram. So the first thing we would want to do is we'd want to say, okay, is there an area formula for the area of a parallelogram? Yes, there is. Okay, so I would jot that guy down on your paper. And again, that's a typical strategy that I suggest for everybody on all problems that use any formulas. Write down your formula. So base times height. Okay, we'll have a look into this diagram. What type of information would we call the base, and what type of information would we call the height? Okay, think the base is 10. Okay, what about the height? Yeah, I think my diagram's a little messed up here. My 7 millimeters there ought to be over here closer to the height. Now, if we did call those the base and the height, which were correct, those are the base and the height. But why are they the base and the height? Is it because the base is on the top or the bottom? Yeah, yeah, exactly. They are perpendicular to each other. Okay, so the 10 and the 7 are two values that are perpendicular to each other, so that is an acceptable place to call base and height. So obviously just finish it off. 10 times 7 is 70, and just get accustomed to the fact that whenever you do an area calculation, you are going to end up with a units of measure in the second dimension. Okay, so you have millimeters on each of the side lengths. Side lengths is a first dimensional measurement. So when you go into area, you're going to end up with a second dimensional measurement, 70 millimeters squared. Does that mean that the 70 is squared? No, not at all. As a matter of fact, it doesn't mean that at all. Okay, it means that instead of just millimeters being a line's length, you've got millimeters going each direction, so you get little bitty square millimeters, and there's 70 of them required to fill up that parallelogram. Okay, so easy stuff. That should be review. Rhombus. Well, good news about a rhombus is that it is a parallelogram. Since it is a parallelogram, we have a formula for finding the area of a parallelogram. So if they want to throw us a rhombus, that's fine. We will take the rhombus and we will treat it just like a parallelogram because it is a parallelogram. Okay, so just like any other problem, when we look at it, ask ourselves, do we have a formula that goes along with finding the area of a rhombus? Yes, we do. The formula is base times height. Okay. So again, base and height, find some positions that we can say are perpendicular to each other. Those can be base and height. So it looks like in this case, that would be the 8 and the 7. Okay. And obviously 8 times 7 is 56. Since it was millimeters, it is 56 square millimeters. All right, our friend the rectangle. Well, once again, a rectangle is a type of parallelogram. We have a formula for how to find the area of a parallelogram. So we will use the same formula to find the area of a rectangle. Rectangle is a little bit easier to work with, which is not to say that any of the other ones have been difficult to work with, but with a rectangle, it is far less likely that you will have very much distractor information in the problem because there's really nowhere to put it. Okay, the base and the height are usually the sides of the rectangle. So there's not really anywhere to hide any distractor information. So for that reason, I would probably guess that you will never see an area formula on a rectangle on a high school tax or star, just because it's too easy. Okay, if they're going to pick on an area problem, they're probably going to pick on a more complicated shape. But anyway, if they would like to find the area of a rectangle, we can certainly do that. We have a formula, base times height. I believe this one is on the formula chart as area of a rectangle, which is fine. Okay, but we also understand that a rectangle is a parallelogram, so base times height. Now in a rectangle, your base and your height, okay, we're still trying to find guys that are perpendicular to each other, but we know that in a rectangle, everything's perpendicular to everything else, right? All the corner angles are right angles. So 3.5, 1.5. Okay. Well, probably most people do not know off the top of their heads what 3.5 times 1.5 is. So we probably have to put pen to paper or maybe fingers to a calculator or whatever the case may be to find out that it's 5 and 1/4 square inches. All right, our friend the square. Slight difference on the square, but it's almost an argument of semantics here. A square is a parallelogram. Okay, so being a parallelogram, it follows the same formula that any of the other parallelograms that we've talked about will follow. The area is still base times height. The only difference in a square is now our base and our height, just like with the rectangle, they're perpendicular to each other. So we're using two of the side lengths. Okay, but as Maya just said, now our sides are all the same also. So when they say base times height, it's actually the same value. The base and the height are the same length. So typically in a square, we don't even say base and height. Usually we just say sides. Okay, this is the formula you guys are probably familiar with. Area equals side squared. Okay, you won't find this one on the formula chart, but let's face it, if you need the formula chart to find the area of a square, we're probably in big trouble. Yeah, base times height or side squared, it's going to do the same thing. Okay, so if they want to throw a square at us and ask us to find area, well, again, I think that's probably on the cutting edge of 5th grade math at the worst. I would think that if you actually do see an area of a square question, they will probably not give you the side lengths. Maybe they'll give you a diagonal or something like that, make you figure out the side lengths. And we'll worry about that a little bit more in the coming days where they don't give you the information that you actually need. But in the meantime, whether you like the base times height formula or whether you like the side squared formula, either way, you're going to figure out that it is 7 times 7. And of course, 7 times 7 is 49. And in this case, 49 square centimeters. All right. You should be familiar with this formula. The trapezoid works a little differently than any of the shapes that we've seen so far, and it's probably the most complicated area formula that we have. In all honesty, in any of the area formulas you've talked about to this point on any shapes. Okay, trapezoid's probably the toughest. We'll get to some other ones here in the next coming days that might be a little tougher. I guess the formulas on the area of a sector and stuff like that we did last unit were tougher than this. Okay, but as far as the quadrilaterals go, this one's the toughest by far. Okay, the area of a trapezoid is found by multiplying 1/2 times the sum of its bases times its height. Fortunately, this formula is provided for us on the formula chart. This is one of the few formulas that I think they didn't waste their space on the formula chart giving to us. This is a good one to have. And it reads pretty much like this one. I know some of you have had teachers in the past that may have stated this formula differently, where they said, the sum of the bases times the height divided by 2. Okay, which is fine. Okay, you can do it that way as well, whether you say it as multiply by 1/2 or say it as divide by 2, you should get the same value. Once again, just like with the quadrilaterals, the bases, okay, because this time we have more than one base. We've had more than one base on all the figures we've looked at, but it hadn't made any difference because with a parallelogram, the opposite sides, the bases, have been congruent. Okay, with a trapezoid, our bases are not likely to be congruent. Okay, but the bases and the height are still going to be perpendicular to each other. Okay, so the thing you need to really remember is that your bases, wherever they are, your bases are going to be parallel to each other. Okay, so bases aren't necessarily top and bottom. They can be left and right. They can be diagonal, but they are the guys that are perpendicular. So watch out for your perpendicular ones. Okay, if you can find those are your bases, and the height will run perpendicular in between those guys. So let's look at a trapezoid. Finding the area of a trapezoid is a fairly common question for them to ask on our end of year tests for a couple of reasons. First off, the formula is more complicated. I tend to lean towards the complicated formulas as opposed to the easy ones. And secondly, in a trapezoid, there is a lot of opportunity for distractor information. They can throw a lot of numbers in there, and not all of the numbers are needed. The more complicated the shape, the more it's probably important for you to get into the habit of writing your formula down, and then identify the necessary information from the figure, and let's plug it in. Well, just going on in the formula from left to right, 1/2 is 1/2. It's built into the formula. It's going to be there. Okay. How about the bases? How do we find the bases in a trapezoid? They are the two guys that are parallel to each other, wherever they happen to be. So in this case, which guys are parallel? The 20 and the 26. Those are going to be our bases. The 20 and the 26 are going inside of the parentheses. Now, which value gets called the height in this case? The 8. How do you know that the 8 is the height as opposed to the 10 or the 11? Yeah, the height is always going to be perpendicular to your bases, so try to find your right angle. So the 8 is going to be the height. We're just plugging in information right into our formula. All right, well, once everything's plugged in, now all we have to do is worry about, please excusing my dear Aunt Sally. Okay, so we're going to look into the problem, and where should we begin working? Inside of the parentheses, absolutely. So even though, please excuse my dear Aunt Sally, says that multiplication should be done before addition, we need to go into the parentheses and simplify there first. So inside of the parentheses, 20 plus 26, what's that? 46, obviously. Now you have a big tie for multiplication. Remember when you're doing your, please excuse my dear Aunt Sally, if it's a tie, like everything's multiplication division or everything's addition subtraction, work the problem left to right. Okay, so we're going to worry about 1/2 times 46 first. What's half of 46? 23. And then that would get multiplied by 8, which again, we probably don't have that one right off the top of our head. We might need to go to a calculator for that one or whatever, but I believe it is 192. Okay. Oh, 184. Sorry, I missed it. Okay. Now, sometimes with this order of operations, like I say, typically if it's tie, you work from left to right. There are some cases where it matters and some cases where it doesn't matter about the going left to right. The problem is it's a very complicated explanation for me to tell you when it matters and when it doesn't matter. So just get into the habit of going left to right. In this case, it actually didn't matter. I combined the two whole numbers, 46 times 8 right there, and then multiplied by half or divided by 2 to get the 184. Okay, but just kind of get into the habit of going left to right. It won't cause much of a problem. Okay, now kites. Kites are a completely different issue altogether. Now, there's a couple of different methods, a couple of different strategies for solving for the area of a kite. Both of them are good. We should know them both. But I'm going to give you a formula that you've probably not ever seen before unless you really had a junior high teacher that was gung-ho on the geometry stuff that he or she was supposed to be covering. And the kite's going to fall under kind of an umbrella type of a rule that basically reads like this. If any quadrilaterals, diagonals are perpendicular. Okay, so that's not just for kites, that's for any of the shapes where diagonals are perpendicular. When this happens, then your area can be found by the formula, and it's written out right there. 1/2 times one of the diagonals times the other diagonal. Now this formula, unless they've decided to change something that I don't know about, they have not previously given us this formula on the formula charts. Okay, so this one, if you plan on using it, is going to have to be memorized. Now, can anybody think of a different way to find the area of a kite? Okay. Well, if you look inside the diagonals, okay, kite's diagonals are going to be perpendicular. So what's that make this little figure up here on the upper left? Right triangle. And underneath, another right triangle, and a right triangle, and a right triangle. Can we find the area of triangles? Sure, and we're going to get to triangles here in just a second. Once we find those areas, could we add them up to find out what the big area of the kite is? Yes, we could do. We could treat it like a composite shape. Like instead of one kite, we could treat it like four right triangles, find area and area and area and area of the four triangles and add them all up. Now this formula says it works for any quadrilateral that has diagonals that are perpendicular. Kite is one of them. There are two others. Anybody remember which other quadrilaterals have have diagonals that are perpendicular? Okay, obviously not. You may want to jot them down. Kite has diagonals that are perpendicular. Rhombus does, and square does. Okay, so this little formula right here can also work for rhombus or square. Now we have other formulas that we can also use on rhombus or square. So why would you want to know this formula and that other formula for rhombus and squared, or rhombus and square? Depending on what kind of information they give to you on a rhombus or a square, this formula might actually be easier to use than the base times height one or the side squared one. Okay, so something to keep in mind, and we'll look at some examples when the time comes on that. Okay, so let's have a look. We have an example here that the problem identifies for us as a kite. Okay, so we could probably make a decision at this point, and it's completely up to you. If you want to treat this kite as four triangles and find those areas individually and add them up, that's fine. You can certainly do that. Or if you would like to use the formula that says, hey, any four-sided figure that has perpendicular diagonals, like a kite does, then we can go 1/2 times diagonal 1 times diagonal 2. Okay, we'll have a look at the diagonals. Okay, what kind of lengths are we talking about here? 8 and 10, 8 and 11. Okay, I'll agree with 8 and 11. Not a big, not a big deal. Just plug them in. We can simplify. Okay, and again, just plugging it in there. 11 times 8 is 88. Half of that is 44. So this kite, pretty big kite, 44 square feet of material, but not a difficult calculation, just plugging it in. It's a handy formula to have, but once again, you are going to have it memorized if you plan on using it on your tax or star this year. All right, here's one everybody should know. We're done with the quadrilaterals. Here is our triangle. The area of a triangle is found by multiplying 1/2 by its base by its height. And if you think about this formula, it makes absolute perfect sense. A triangle is basically half of a rectangle. So it doesn't get the entire base times height formula like a rectangle does. It just gets half of the formula because it's half of the shape. And so 1/2 times base times height. And once again, when you're dealing with a triangle, just like with any of the quadrilaterals, your base and your height, wherever they are, they don't have anything to do with being on the bottom or being going up and down or anything like that. It has to do with the two sides that can be perpendicular to each other. So 1/2 times base times height, and you will find this formula on your formula charts. So let's take a look at a triangle. Not a big deal. You've probably done this calculation for years. All right, so all we have to do is identify the appropriate information, plug into the formula. And as I'm sure you can guess, these problems get more complicated when the information or the measurements that we need when they're missing, and we have to do other stuff to figure them out. And we'll look at how to do some of that stuff tomorrow. Okay, but for right now, we're just getting the basics with the formulas. Okay, in this particular problem, we have a 6 and we have a 4. Are they the base and the height? Yes, they are. How do you know this? Because they're perpendicular to each other. It doesn't have anything to do with where they are. It has to do with whether their sides are perpendicular or not. Since they are, okay, you got the 6, you got the 4. Just plug it in there. 6 times 4 is 24, and half of that is 12, and there you go. You've got 12 square meters in the area of this triangle. Anyway, that's it. So we have some problems to practice along with, just basic refreshers of some of the old formulas you've known for years, and maybe a new formula in there with the area of the quadrilaterals that have perpendicular diagonals. But anyway, get to the worksheet.